So if you've ever used an AI, you've probably done the usual stuff. Summarize an article, help you write an email, maybe fix some code. But what if I told you there's a way to use it that's, well, it's so different. It's like comparing a kid's bicycle to the space shuttle. We're going to dive into this because this is a powerful, structured way of using AI that goes way, way beyond those everyday tasks.
Right. So on one hand, you have how pretty much everyone uses AI. It's a fantastic search engine, a writing assistant, a coder's best friend. That's the standard. But what we're looking at today is a whole different beast. We're talking about something called cognitive orchestration, turning a single AI into a multi-agent lab, a disciplined, structured workforce for research. This is a complete paradigm shift.
And get this, to really hammer home how different this is, when the AI model using this protocol was asked if this is how people normally use it, this was its answer. Honestly, not like this. The source material says the number of people doing this is tiny, so this isn't just some clever prompting trick. It's a fundamentally new methodology. Okay, so what is this strange new method? Well, it's not about writing better prompts. It's about building a complete research operating system on top of an AI. You can think of it like installing a whole new layer of rules and logic that turns this general-purpose tool into a highly specialized, high-performance research engine. The core idea here is called cognitive orchestration. And just listen to that language. We're not chatting with an AI. This is structured management of an AI swarm. It's about commanding it to act like a disciplined lab. This is all about control and precision, not just having a casual conversation. So how do you get that control? Well, it's built on two pillars. First up, you have the Constitution. This is basically a set of ironclad laws the AI has to obey no matter what. It includes things like the single artifact rule, which means one task produces exactly one output, period, and halt commands to stop the AI from ever wandering off topic. And the second pillar is the playbook. So if the Constitution sets the fundamental thou shalt not rules, the playbook gives the super detailed, here's exactly how you shall instructions. It defines all the different roles for the AI, the precise format for every task, and the step-by-step process for how the whole research project is going to unfold. So we've got the laws, and we've got the procedures. How does this actually build the lab itself? Let's take a look at how this works in practice by meeting the team, the AI research team, that is. First up, you've got the project planner, a role called the overseer. Think of this as the master architect of the whole project. It takes a huge, complicated goal and breaks it down into a perfectly clear, sequential list of small, focused tasks. This is the master planner, designing the whole thing from beginning to end. Next, we have the workers, the contractor brains, which the protocol calls iterators, and that name is perfect, because each iterator is given one and only one task from the overseer's to-do list. It executes that single task with laser focus, produces one specific output, and then it stops. That's the single artifact rule in action, enforced with total precision. And finally, there's the final reviewer, a role called the integrator. This AI agent is the quality control specialist. It doesn't even wake up until every single task is finished. Its job is to gather up all the individual pieces made by the iterators, check them against each other for consistency, and then merge them all into one single coherent final product. So what you end up with is this crystal clear workflow. It's a simple but incredibly powerful pipeline. The overseer plans it all out, the iterators execute their individual jobs, and then the integrator puts it all together. There's no room for confusion, no going off script. It's just a clean, straight line from a big idea to a finished, integrated result. Now, you might be thinking, why go to all this trouble? Well, it's because this system solves the two biggest headaches of working with large language models. First, it prevents drift, when the AI just wanders off topic or writes way, way too much. And second, it prevents sprawl, that explosion of disorganized files and constant scope creep. This system forces the AI to be a totally compliant and bounded research assistant. But this isn't just about being neat and tidy. The protocol has a much bigger, much more ambitious goal. All of this structure, the Constitution, the roles, the workflow, it's all designed to achieve a level of quality and reliability that you usually only find in formal academic science. And here it is. This is the end game. The ultimate goal is scientific reproducibility. The whole point is to create research that isn't just interesting or clever, but that is totally verifiable, auditable, and repeatable by anyone else. That right there is a cornerstone of all science. And it gets there through this incredibly rigorous automated auditing process. It uses a series of checks called batteries. And believe me, these are not simple spell checks. For instance, a static audit is kind of like an architect checking blueprints for forbidden materials before a single brick is laid. A golden manifest check is like a digital tamper-proof seal on an evidence bag, making sure nothing has been messed with. It is an unbelievably deep validation process. And this is the payoff. This quote just sums it up perfectly. What you get is a locked, reproducible, fully tested snapshot. The final output isn't just an answer, it's a verifiable artifact where any future change, no matter how tiny, is immediately flagged. Now that is true auditability. All right, let's zoom out. We've seen the what and the how, but what does all this mean for the future of research itself? What are the bigger implications here?
And it is so important to understand this protocol was not designed for small-time tasks. It was actually developed to push forward a speculative physics framework. This is a method for tackling grand challenges, the kind of complex, high-stakes problems that you find at the very frontiers of science. And that's why this comparison from the source material is just so perfect. Using this system is closer to how a real research lab or even a DARPA program would manage huge teams of human experts than it is to just typing a prompt into a chat window. This is an industrial-grade framework for scientific discovery.
Which leaves us with this one final, really provocative question. We've just looked at a system that forces discipline, guarantees reproducibility, and lets an AI tackle huge scientific challenges with verifiable rigor. Could this be more than just a cool experiment? Could we be looking at the actual blueprint for the future of AI-driven science? Definitely something to think about.